So this is problem 18 of chapter 8 of Giancoli 6th edition. So we have a wheel and the diameter of this wheel is given to us. So we have the diameter and if we have the diameter, we also have the radius of this wheel, right? It's just the dimension, the diameter divided by 2. Careful, this diameter is given centimeters, so you'll probably prefer to convert it to meters. And it says that this wheel is accelerated uniformly from a certain initial frequency to a new final frequency. And they give us the time that it takes to accelerate. The time is given in seconds, while the frequency is given in RPM, so revolutions per minute. So you probably would prefer to change the from revolutions per minute to revolutions per second. Okay, so the question of this problem is how far will a point on the edge of the wheel have traveled in this time? So here I have the wheel with a certain point A initially, and as this wheel rotates, this point A moves around and it travels along this edge. So the question is, how long has this point moved at the edge? In other words, what is this arc here? So this is the question. This is the unknown of the problem. To find this arc that the point on the edge has traveled, a good alternative, a good approach is to find the angle that it has traveled. No? So to find this angle here. With this angle, I can find the arc. Okay, to find the angle, I'm going to use this equation. This is a motion that is accelerated with uniform acceleration, so I'm going to use this equation to find the angle theta. The angle theta is the initial angular velocity multiplied by the time plus the angular acceleration divided by 2 multiplied by the time squared. Let's see if we have all of these different terms. Well, the initial angular velocity we do have because we have the initial frequency. So we can just obtain that by doing 2 pi multiplied by that frequency. Careful again with the units. Now, how about the angular acceleration? We can also obtain that because we have the final and the initial frequency. So we have the final and the initial angular velocity. And with that, we can find that angular acceleration. And we also have the time. Okay, so once we have the angle theta, that the particle moved, that the particle traveled, we can then find the arc. And how are we going to find the arc? We just use the relationship that we found for angles given in radians. Remember, all these units that we are using here is radians per second, radians per second square. So the angle is L divided by R. We found the angle and we have the radius because we have the diameter. So with that, we can find the question of this problem, which is how much the particle has traveled.